Good morning, everybody. I think you can hear me. So we will start this new module called Virtual Engineering. So under this module, what we are going to do is basically we are going to introduce you the CAD software called SolidWorks. And under SolidWorks, we are going to look at how to draw 2D, 3D CAD models, solid modeling. And after the modeling, I'm going to show you how to simulate the designs and get some results. So we will do 2D, 3D CAD modeling, CAD solid modeling, and we are going to mesh the boundary mesh. We are going to mesh the models and apply boundary conditions. And at the end of the day, we are going to do some structural and fluid dynamic simulations and get some results. So I hope you can hear me. So if you can't hear me, you can always ask any questions. You can tell me. So I hope everyone is having SolidWorks with you at the moment. So we are going to start with SolidWorks. I heard that you haven't learned any CAD software before. So you haven't done any engineering drawing or AutoCAD or whatever the things related to drawings. So sometimes this may be somewhat new to you. So normally we don't start directly with the SolidWorks. We start with manual drawings and we go to AutoCAD and come to SolidWorks. So here I'm jumping directly to SolidWorks depending on the time limitations we have. So this subject is somewhat a big module, and this is actually should taught separately, and 2D CAD modeling and finite element analysis should be taught separately. But here they have given everything in one module. So at the end of the day, we are going to do some computer-based modeling, and you will get assignments based on this computer-based modeling, and you have to do some finite element analysis. It may be structural or CFD, actually both structural and CFD simulations, and we are going to determine the results and we are going to predict the results. So this is the basic idea of this module. So we need a computer, we need SolidWorks. So I hope everyone is having SolidWorks with you at the moment, otherwise it's useless to participate to this class. So you can read these learning outcomes. They talk about 2D, 3D CAD modeling, solid modeling, and they talk about finite element analysis, beams, and they talk about CFD, computation and fluid dynamics. So these are actually big subjects. So here we are going to do some introductions only. We can't go in deep in every area. So actually we are touching the surface, so I am trying to give you as much as possible within this limited time. Then we are going to predict the results and interpret the results. So this is the learning outcomes. So I will give you the assignments soon. What is the assignment we are going to do? So I hope you understood the concepts behind this module, what they want to learn. And we will directly start with SolidWorks. I hope everyone is having the software with you. If you have any, if you haven't installed this, I think they have shared the link with you. Please quickly install the software. We are going to start directly the drawings. So we have to start with 2D drawings, and we are going to model 3D. So I hope. So I gave these notes for you, first 4 notes. I shared the first 4 notes. So today we will try to touch all these 4 notes, 4 slides. So we will start it. Any questions about the module? I hope you can hear me. If you can't hear me, tell me. So you can use any SolidWorks version, but better you use latest ones. So I have 2016. So 2017, 18, 19, even 2020 we can use. So I'll start with SolidWorks 2D CAD modeling, and we are going to do 3D also today. Then actually, if you study this in depth, you will be able to do something like this kind of modeling. So actually, we are doing these kind of things in our institute also. So these kind of models are uh, very easy to draw in SolidWorks. So you may not touch up to this level because of the time limitations. But I will try to introduce the areas so you can later study by yourself and master the subject. So these kind of things are we do for our BSc engineering students. So we will start this. So I'm Niranga. I'm from SLIIT. So I did mechanical engineering in Moratuvar. So my areas are CAD, CFD, and finite element analysis. So we will start the software directly. So what do you mean by? I hope you have heard about SolidWorks before. So this is a US-based company. So this is called a feature-based parametric solid modeling mechanical design software. So what do you mean by feature-based is you have features in your model. That is, if you take say I'll take an example. So this is a pen. So this is an assembly file. So assembly file means this pen has lot of parts here. So this tip is a part, this tube is a part, this spring is a part. So you have lot of parts in this uh, assembly model. So pen is an assembly, and assembly has lot of parts. So in SolidWorks, we talk about assembly drawings, we talk about part drawings, and we talk about drawings. So we model the parts and we assemble the parts and we get the drawings. So in the part mode, what we do is we draw all the features of the parts. So we draw the features. That is, if you talk about this simple drawing, and if you take this tip here, this is a part, and this has lot of features. So one feature is the circular shape, and there's another conic shape. So those are features. So we are trying to draw the features here, and here the tube has a circular cylindrical feature. So we have the parts, and inside the parts we have different features. So these features are drawn according to measurements. So this is not like cartoons. This is real drawings, real engineering parametric drawings. So you have the parameters here. So here, if you look at the words here, you have features. So if you take a pen tip, if you talk about a tip of the pen, so this is a part and it has features. That is, you have this cylindrical shape, there's a hole here, and there's a conic shape here. So those are the features, and those are based on parameters. Parameters are the height here, diameters, angles. Those are the parameters. So you can easily change the diameter, height, angles, and change the tip shape. So we can quickly edit our drawings in SolidWorks compared to, say, AutoCAD or manual drawings. Manual drawings, it's very hard to change the drawings. You have to erase everything and redo. But in the computer-based modeling, you can quickly edit your drawings. And after you design these parts, you can assemble it. So assembly mode is done in two ways. One is bottom-up assemblies, and the other one is top-down assemblies. Bottom-up assembly means you draw the parts separately and you assemble one by one. So it's like our normal day-to-day life activities. We manufacture part by part and we assemble separately. But there's another interesting method called top-down assemblies. Top-down assemblies, you don't draw parts separately. You directly go to assembly mode here and draw the parts while assembling. So it's like a simultaneous process. You draw the parts and assembling at the same time. So this is good when you do complex designs. So what happens in the bottom-up assembly is normally if you don't consider about the measurements critically when you try to assemble this, there will be problems, there will be interferences, it's not matching, sizes are not fitting with each other, there are problems in bottom-up techniques if you don't care about the measurements critically. But in top-down method, what we do is we draw this one in the assembly mode directly, we don't draw separate parts. And we draw this part on top of this. While assembling, we develop the things. So bottom-up assembly method is somewhat top-down assembly method is better than the bottom-up assembly method. So I hope you understood the difference between bottom-up and top-down. We used to bottom-up normally. We it's like building a house. We put the foundation and put the walls and set up the roof likewise. So top-down assemblies, we can have the big concept in my mind and we detail it out later. So and after we get the assembly drawings, we can generate the assembly models, we can generate the drawings. So there are two ways of getting drawings. Either we can generate the drawings from part mode directly or assembly mode directly. Software will automatically generate the drawings for you. Or else you can draw your uh, parts as AutoCAD in SolidWorks also. So since you haven't done AutoCAD, you may not familiar with what I'm saying here. Here software will generate everything for you, but this one I have to manually draw. So you need to have some basic understanding about manual drawings and say 2D CAD drawings. But here we don't have time, so I will introduce the 3D models. While we are doing the 3D, you will get some understanding about the 2D basic concepts also. So this is how it works. First few days we are going to look at how to draw the parts. Then we will quickly touch the assembly areas and we try to get some drawings. And later I have to go to simulations also. So first 5 weeks will be around, we are talking about these things. Next 5 days we are going to look at simulation. So it's something like a difficult task to achieve. So we will try to cover as much as possible because this is done separately as a subject in 4-year degree courses. So since you don't have much time, they have compressed everything into one module. So I will start with part mode. So we are going to start with the software directly. We will start to have a small, we can go through these things later when it needed. So I will start with a small drawing with you. So I hope everyone is having the software with you at the moment. So we will skip these things and I'll try to start chapter 2. Start chapter 2. And try to come every day to this class, otherwise you will end up with nowhere. You will not understand what I am doing. You will not be able to model anything. So this is a continuous process, not like a normal theory class, 100% practical based. So it's better if we have do it in a lab, but since we have corona, we can't meet with each other. So I'm going to model something like, say if I want to model a solid spanner like this, how can I model in SolidWorks? So we have to first do 2D sketching. So we cannot directly obtain this shape. So we have to draw this simple 2D sketch. And after we do this simple 2D sketch, this is called base features. So we have to do the base fundamentals or foundations first, and we have to add some thickness to that. So after we do the 2D sketch, we have to add some thickness, that is called extrusion. We have to do some extrusion here, and after we do the extrusions, we have to do some cutting, and we have to put some 3D text here, so we can finish our drawing now, and we can apply some fillets here, round corners. So you can see how it develops. We can't directly do this. We have to do this one, then this, then this. So what we are going to do is, in the first few hours, we are going to look at how to model 2D sketches. We cannot directly go to this stage. First, we have to master the 2D sketches, then 3D then we have to go to 3D. So we will start the software, and I will start a simple sketch with you. I will not go through all the sketching tools. When it requires, we will do it, since we don't have much time. So a lot of sketching tools are available. We will start with this simple design. So I will put this in the side. So I'm in chapter 2. Better you download these notes and look at the tutorial. So I'm going to, this is like a tutorial based class. So we will start with this tutorial. Uh, so here we have to model this shape. So when we try to model this shape, uh, we are starting with this normal 2D sketch. So we will start with the simple one, tutorial 2. So I want to obtain this 3D model, solid model. So what we are going to do is, we are going to do this, draw this 2D sketch and add some material. So we can draw the 2D sketch and make it a 3D. So when we do the 2D sketch, we have to make sure that all the dimensions are given, all the relations are given. That is, this is equal to this side is equal to this side is equal to this side, and all the dimensions should be given. Otherwise, what happens is, if you don't give adequate dimensions, the model will be not stable. So it's not going to be a fully defined sketch. So you have to do a fully defined 2D sketch and make it 3D. So how can I do this? When I want to do this kind of a drawing, we cannot directly start in SolidWorks. We have to select a plane and start, and we have to give these. We have to use the line tool and the circle tool or the arc tool. So we'll look at how to draw this in SolidWorks now. If I'm going fast, tell me. I will try to reduce my speed. So now, when you start the SolidWorks interface, you get something like a blank interface, and I'm going to start with a new file here. So if you want to repeat this process, tell me. I will repeat this. Starting with a new file, and you will get three different areas. One is called part mode, assembly mode, and drawing. So as I told in the slides, we have to start with the part mode, single designs. So I will start the part mode. So when you start the SolidWorks for the first time, they will ask you the units. Normally we use millimeter, kilograms, units. So you don't use centimeters or meters in SolidWorks. So when you start for the first time, it will ask you these units. Here it's available, millimeters, grams, seconds. So if you select millimeters, grams per second when you start for the first time, always it comes as millimeters, grams, seconds. So make sure you select this one when you start the software. And ISO or NCO, whatever the standard you can select. So dimension standards may be ISO or NC or BSI. Whatever this dimension standard is not a major problem, but select this as the unit type in SolidWorks. So all the drawings what we do is in millimeters. Sometimes we will do it in inches. Normally we don't do in centimeters and meters. We don't do. So you can go to edit document units and change the units even. So we will look at these areas when we need. So start with that millimeter thing. So I will start again, part mode. Now this is again empty. So when we try to draw this kind of a drawing, we have to select a working plane. So in the software, they have introduced three planes: front, top, and right. So this is the front view of a drawing. This is the top view of the drawing. This is the right view. So if you just look at the front view here, front view will be this one. And this is the right view of the drawing. This is the top view of the drawing. So if you talk about a house, house front is the front plane. House top roof is the top plane. House right side view is the right plane. So you have to select the correct plane to start the work. So better you select front plane and start this work, because this is the front appearance. When you try to generate the drawings, this will be coming as the front view of the drawing. So don't select top view here, because it's not suitable. So we have to draw this and make it 3D. So we have to select the front view. So I'll select the front view. When you select the front view, it's selected. So I'll start from the beginning again. So start it here. You can select the front view and start, or else you can directly go to sketch and start the sketch mode. Click here, and all the planes are shown. Then it says select a plane to wish to create the sketch. So I'll select this one. So once you select this one, automatically the front view will be facing towards you. Now what we are going to do is, I'll minimize this screen. This is the problem of teaching these kind of subjects online. Screen problem. So I'll select the front view, and I can start from here even. So you can go from here, or else you can select the front view and start the sketch. Now I have to minimize this. Now we have to draw this. So this is a symmetrical drawing, meaning that if you draw a center line from the middle here, it's symmetric. So this is my origin in the drawing, origin. So what I'm going to do is, I'm first trying to draw a center line in the drawing. So center line will make sure your drawing is symmetric. So you go to line tool here and select the center line, and it says as sketch. So you are going to draw a center line like this. So going through the origin. So I drew a center line which was not available here, but we need it because we need to make it symmetric. So center line was drawn. Then center line is drawn. Now I have to sketch this outlines, outer border. So we want to use the normal line too. So in SolidWorks, not like AutoCAD or manual classes. Manual classes in an AutoCAD, we have to draw accurate drawings, 100% accurate. Because manual drawings we cannot edit it easily. AutoCAD also we can't easily edit. But in SolidWorks, 3D models, 3D software like SolidWorks, Pro Engineer, CATIA, whatever the 3D software, they can easily edit their drawings. So I can use the line tool, and I'm going to draw here a rough sketch. I don't need to care about actual values. I will just draw a rough sketch. So this is my origin here, and what I'm going to do is, I'm going to start with this point and draw. I'm not going to start with this one and draw, because in the middle I have a circle or an arc shape. So if you start from here and ends up here, you have to move on to arc shapes and again start the line too. So that is not a good approach. So what we do is we start with somewhere here directly from the line tool, and we roughly draw the sketch. This is like freehand sketches. We roughly draw here. We don't care about the actual sizes. So I am roughly drawing this. Now I can press the escape key. So once I drew this, you can see some lines are blue, some lines are black, and some relationships appears. This is a vertical line, this is a horizontal line, this is a coincident. uh, these points are coincide with each other, so some relations, these are called relations, software is putting for you. So these relations are important to have a stable sketch. So this sketch is not drawn according to measurements. I can put the dimensions from here. There's a tool called smart dimensions. So we click on this, and we just click on this line, and it says 354. Now my drawing is only 60, so I'll put the value 60 here. So it adjusts automatically according to my measurements. Now this is 35, so you can see it's adjusting, and I have to make sure that this is equal to this. So you can just click on this line and this line, and the relations appears. Now press the control key and select these two lines, and you can apply some equal relations. So this
Excuse,
is equal to each other, so you put the equal
excuse
symbol.
me, sir.
Now
I have a question.
excuse me,
Excuse me, sir, I have a question. I feel like we are going too fast.
excuse me, I'm going fast.
Yeah.
Yeah, I will do it again. Since you haven't done this, there will be problems first few days. So I will do.
Okay.
Are
Okay.
you okay with starting the software?
Yeah. Yeah.
Okay, so I will read.
Okay.
So we will start from the beginning. So first we have to select the new and go to part mode. So when I select the part mode, uh, I am in the part mode in the SolidWorks software. So we have to do the sketch. So we have to select the sketch to do. Now if you get lot of sketches, this is a single sketch. Some drawings we have lot of sketches. Some models we have lot of sketches. Here since we have a single drawing, it's easy. So we have to decide whether I should draw this in the front plane or the top plane or the right plane. Normally, if you want to show this as the front in the drawing, you have to draw this in the front plane. So if you are modeling a house, this is your house front view. This may be your roof view, top view. This is your right view. So here, it's easy to select the front plane. So you can do what? You can select the front plane and start sketching from here, or else you directly start from here and select the front view. So once you do that, it will be angled towards you, and this is your origin. And now I have to draw a center line. Why I'm drawing a center line is I have to make sure that my drawing is symmetric around the center line, even though this is not given. In the drawing it's not given. In the drawing there is no center line given, but you have to draw it. So that's up to you to decide. Looking at the drawing, so I drew a center line and press the escape. So when you draw the center line, it's going through the origin, and you can see coincident symbol appears, vertical line symbol appears. Now what I'm going to do is, I'm going to draw this sketch. So what I started from here because this is a semicircle or an arc. So if I try to start from here and comes here, I have to move to arc tools and again start the line tool. So it will waste my time. So I'll try to finish everything from the line as much as possible and draw this later. So that's the approach I'm going to follow. So we will start with the line tool, and you can see this is the origin here. So line tool should start collinear to this origin. So I have to start the line tool somewhere here. So I will start from here, then click here, click here, click here, click here. Now this is going through here also, it's not a big issue. So clear, click here, click, 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 click. So these are rough sketches. So this coincident I don't need actually. So if you don't need any relation, I can just click on this and delete. So you can see it's deleted. So sometimes automatically puts unnecessary relations. I don't need that. I delete. Now I drew a rough sketch. Now what should I do next is I have to have this one equal to this one. Even though it looks like equal, it may not be equal. So you can see it's not equal. Even though it looks like equal, it's not equal. So you have to make sure those are equal. So what we can do is we can click on this, press the control key, click on this. So once you select two lines, it's selected as two lines here, and relations appears. We have to select equal. So equal symbol appears. You can see it's adjusted now. So what happens now here is when I move this is moving with that. Both are moving. Then this should be equal to, press the control key and select the two lines. Equal. Now you can see it's adjusted. So when I click, when I do this change, still it's not symmetric. So this is equal to this one, and it should be symmetric now around this center line. So we can select this line, center line, and this line. Press the control key and select all the lines, and symmetric relation should be applied. So I apply the symmetric relations. Now symmetric symbol appears here. You can see now it's change in symmetrical. So this should be allowed when you do a modeling, because we should allow the editing facilities. So if someone wants to edit the model later, it's easy. Now if you look at my 2D sketch, this is 10, this is also 10. So actually this is equal to this one. So it's not given in the drawing, it's given as separate 10 10, but you can make sure this is equal to this part also. And if you apply that relation, this is equal to this, and since this is symmetric, this is equal to this. So I am selecting all the 4 lines and make sure this is equal. So you can see all the things are now adjusted. So I gave a lot of relations now. So this is horizontal, automatically vertical, vertical. These two are equal. So you can look at the numbers here. Number 4, number 4. That is this equals to this. Number 4s are same. Number 6. Number 6 here. Here number 6. Number 7. Number yes, the 7 7. 8 8. So he is matching the parts, lines. Then what we can do is we can apply some dimensions. So after I give the relations, necessary relations, just apply some dimensions. I'm going to apply these dimensions. So the first one is I should have I'll apply the 60 because it's the biggest one. So we will go to Smart Tools here and apply 60. So it's automatically adjusted. Then we have to apply 35. This line. You can see some lines are getting black now. Black means that line is fully defined. Fully defined is that line is the necessary relations, the necessary dimensions are given. Some lines are still blue. That is, it's still unstable. So it's not defined fully. So you have to make sure that all the lines becomes black at the end. If you look at this bottom sentence here, underdefined. So it's not fully defined sketch still. So you have to have fully defined sketches. The meaning of fully defined is your design is stable. You can easily edit the model without any failures. So we are talking about big models. This is a simple sketch. So if you talk about the vehicle engine, so if you have unstable sketches everywhere, so if you change something, or the entire engine model will collapse. So your drawings will fail. So there will be a lot of issues coming when it comes to complex designs. That's why I'm stressing about this underdefined, fully defined theory. So 60 and 35 given. Then we have uh, 10 here. So I will just give 10 here. So I don't need to give everywhere 10 because I made equal lines. So when you look at this now, all the lines are getting black. So it's still underdefined because there are some blue dots still available because this line drawing is not closed. So you can stretch these things if you want. And lot of lines are becoming blue, and I gave a lot of dimensions. This is 10, this is 10, this is automatically becomes 10. So if you try to give 10 here, what happens here is, sorry, what happens here is I don't need to give it 10 because I made this one equal, 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 equal. So it's getting we are getting a warning saying that make this dimension driven. So that is you have two kinds of dimensions in SolidWorks. One is a driving dimension, which is a powerful dimension, strong dimensions. These black ones are strong dimensions, powerful dimensions, driving dimensions. And if you try to have additional dimensions, software will warn you this should be a weak dimension or a driven dimension. So what happens here, if I obey this and press OK, you can see it's a gray color dimension. It's a driven dimension. 35, this 10 is a powerful weak strong dimension. This gray color 10 is a weak dimension. So what happens here is when I try to double click and change this, say I will change this to 12, automatically this is changed into 12. So this is a driving guy. He's in the driving seat. This is a passenger. He's a driven person. He's automatically changed. If you double click and try to change this, it says the dimension selected is a driven dimension. Its value cannot be changed. So you don't need this actually in the drawing because I gave the equal relation. If I delete the equal, this is becoming a driving dimension. So I hope you understood. So when you change this, the driving guy, the driven guy will automatically change. But you can't double click and change the driven guy. So we don't need this actually, we delete this. It's not needed. But what happens if you do something like this? If you say leave this dimension driving, now there will be two drivers. So if you do this one, what happens here is you get over-defined sketches. You can see it's red color here. Over-defined drawings, there is a conflict. So there will be problems. You cannot have two drivers for a single dimension. So it's like we are having two steering wheels in a car. So what happens to the car? Car will end up with nowhere. So you cannot have two drivers for a single dimension because this equal sign is there. So if you delete this equal sign, there will be no problems. Sketch is still over-defined, say 5. So there, since these are equal, there will be problems still. Now there is no problem. So we can independently change this. I hope you understood what I mean. So if you give relations as well as the dimensions, same dimensions, there will be problems. So if I am undoing this, we can undo this from here. Always press the Ctrl Z button. We'll undo this. This is the situation.
Sorry, excuse me.
Yes. Yes, I can.
Hello.
I can hear.
So can you please explain again to how to create the mirror effect?
So I'll undo the sketch. Still there is symmetric symbol. Now there is no symmetric symbol still there. Now it's not there. So this is what happens without symmetricity. So
So excuse me.
yes.
So what will happen if we select dimensions without selecting symmetrical option?
If you don't select symmetrical option, you have to give lot of dimensions, or you have to make other lines equal. This is equal. Lot of things you have to give. Symmetric is, if you give symmetricity, it's very easy. Otherwise, you have to give lot of dimensions to obtain that symmetricity. That's the problem. That's why
Otherwise, you have to define the dimensions to all the single lines, right?
I didn't get you. Hello.
Hello.
Yeah. Can you tell me again?
Yeah. If we don't define the mirror effect, we have to define dimensions to all the lines, right? The both
Lot of
sides.
lines, not all the lines. Lot of lines.
Okay.
Because this side, you can see this side I haven't given lot of dimensions. Only this side we have dimensions. So this is coming from the symmetricity and the equal relations. So actually in this drawing we don't need to give this one also, because this is equal to this one. So we don't need this one. So we may not need this one even. If you carefully look at this drawing, we may not need this one even. So this is for the manufacturing. So this is not for the SolidWorks. This is for manufacturing they have given. If you look at this one 10 here, and this is 10 also, and
So
yes.
So if we select same dimensions for two lines, is it automatically selected as symmetrical or?
No. I will do this again. Then if you carefully look at this one, this radius is 10. That is from here to here it's 10. Okay. From here to here is 10. This is 20. That means from here to here is also 10. So actually this is 10, this is 10, this is 10, and this is also 10. So if you carefully look at this drawing, you can make this line equal to this line and equal to this line even. So all these three lines are 10. So I am looking at the dimensions and deciding it, and these three lines are also 10. So we can reduce our dimensions further. We don't need to give this 20 even at the end of the day. So if you carefully look at 10, 10, 10, 10 plus 10 is 20, 20 plus 10 is 30, 30 plus 10 is 40, 60 minus 40 is 20. So this radius, this diameter is 20. So if you carefully look at, everything is 10. 10. So I will apply that one, then you don't need to give lot of dimensions. So we will do that. So symmetricity we can apply from this way. We can click on this line, press the control, click on this, press the control, click on this. So three lines selected, symmetricity. Now I can make this equal. This one equals to this one, equals to this one, equal to this one, and this, and everything is equal. So you can see all the lines are now equal. These three equals to these three. So it's easy now. Now if you adjust the model, you can see it's nicely adjusting according to some relations. Then we will put some dimensions. This is 60, 35. So don't worry about drawing according to dimensions. Later we can put the dimensions. Apply the relations first. 60. This is 35. This is 10. So you can see that everything is now becoming black. If you look at the model under here, it's fully defined. That is, I have done a correct drawing. Don't worry about this blue dot here. It's a symmetrical line. So there's a blue dot here at the end. if you want to make it black here, you can do it easily. You can make it fix to the screen, so you don't need to do that because it's fully defined. So if you want to make this as a black dot, you just click on this and make it fixed. Now it's becoming black. Now it's also fixed to the screen, so it's not a mandatory thing. No need to do it yeah, because this is already fully defined. Now you can see if you try to put the dimension for this one, it's going to be driven dimension. Or if you try to make it over defined, this is the result. So you can see over defined. So this is not encouraged. This is a wrong thing to do. So you don't have over defined sketches in SolidWorks. So don't do that. Or what if you want to really put a dimension, what we can do is we can just make it a driven dimension. So just click on here, make it a driven dimension. That's all. This is just for visualization. This is just for the manufacturer to get the dimensions easily, because he may not know whether there is 10 here. So we are giving some additional dimensions for him. So you can see the gray color. This is pure black. This is light gray color. These are strong dimensions, driving dimension. This is a weak dimension. So this is actually not needed. Now we have to draw the other part, the semicircle. So I think you haven't done any drawings before. So what we can do is we'll use a arc tool here. So there are tools called arcs. We don't need to draw circles and cut the circles. So if you want, you can draw a full circle and cut the top side, but we will not do that now. For the time being, we will use this arc tools. What are arc tools? Arc tools are partial circles. Arcs are kind of circles, but it's not a full circle, it's a partial circle. So you can there are three ways of drawing arcs in SolidWorks. One is center point arc. Center point arc is, I'll just have some theory here. Center point arc is you just point a center, locate a center and draw the arc like this. So this is called a center point arc. We give the center here and we give the starting and ending. Center point arc. And there's another one called 3-point arc. 3-point arc is we just give 3 points in the screen and draw the arc. So I just gave the first point, end point and the middle point. So this is the 3-point arc. First one is called center point arc. We need to know the center. Here we don't need to know the center. We need to know at least 3 points in the sketch. So if you try to draw it here, center point arc, we can get the center here and draw an arc from here to here. So center given, starting ending points given. And there's another one called 3-point arc. 3-point arc is we need to know at least 3 points. First point, second point and the third point. So this is a 3-point arc. And we have another one called tangent arc. Tangent arc is, it should start with another arc or a line, something like this. These are tangent arcs. So you can see the tangent symbol appears. Tangent symbol appears. I hope you know these terms in mathematics. Tangent symbol appears. So tangent arc starts with a line. Say I can draw from here even a tangent arc. It should have some support. So if you try to start a tangent arc in an empty space, it won't work. It will work, but it doesn't give any idea. So you have to start the tangent arc from a line or another arc. So this is about the arc theory. You can just draw the sample arcs and see. Now I have to draw something like a semicircle here. So we can use all these three. Actually the easiest one will be the center point arc, because I know the center already. Center is in the origin. So I had the center line in the middle nicely. So I it's here. I had the center line in the center point in the middle. Nicely, center line is going here. It's very easy for me now. If you haven't considered about that one and drew the sketch, you have to use something else. Say I can use tangent arc even. 3-point arc we can use. Center point arc I will use. Get the center and draw the arc like this. So you can see arc is drawn in the other way. You can just hover the mouse and get it correctly this side. So I drew the arc. So when I draw the arc, it's also becoming black. So I don't need to put the measurements. Black means it's fully defined. I don't need to put a measurement. So if I try to put a measurement, the same problem comes because this is 10, this is 10, 10, 10. For 60 minus 40 is 20. Automatically this becomes 20. Diameter 20, radius 10. So automatically software calculates that for you. So you can make it driven measurement if you want. Or else you can skip this. I don't need to have it in my drawing. So I'll draw this again. Arc shape. Earlier I used the center point method. Even this video is recording, so if you want you can look at it later, no problem. So if you have problems, you can always look at this video again. And we have our YouTube channel also about SolidWorks. So I have recorded a lot of videos in when I teach our SLIT students. So this is my channel. I will show it. Sometimes you may have heard about us. If you have worked with electronics, you may have heard about us. So this is our SolidWorks lecture notes. Actually, we don't have the first few lectures in our channel. So you have it from, we have the drawings, assemblies, chapter 9, chapter 7, 6. From chapter 6 onwards, you have the notes in our channel. So first 5 chapters, we don't have notes. So I am doing for the first 5 chapters, we don't have. So for the 5 chapters, we don't have YouTube videos. I can put this video in the YouTube even. So from here onwards up to this point, we have YouTube videos in our channel. So this is my channel. So everywhere you can find all the tutorials, everything. Later also you can go through these things. So we are doing these kind of good models in our video series. So if you look at our chapter 10 tutorial, we will do these kind of things. I will try to introduce all these things. Time is the problem. This is a full semester work. So CAD is only, you have SCAD and finite element, everything in one semester. That's the problem. So this is a full semester work. So we are doing these kind of models necessary for our engineering students. So if you want, you can look at our channel also. Assembly parts are also assembly lectures also there. So I will try to introduce these things. I may not do everything with you like other guys. So gear wheels, lot of things are there. So it's up to you to actually get the maximum from these resources. So I'm teaching all these things. Okay. So this is the starting. Automatically the calculation has been done. So we will teach you these. I don't think we can do these things with you because of time limitation. So you can go through these slides if you want. So if you really want, we have AutoCAD notes also. So in our playlist we have Revit also. I hope you have heard about this. AutoCAD notes also from the beginning we have. So today we are going to look at how to draw from beginning AutoCAD display using AutoCAD. So we will first look at some basic. Okay, so this is about our channel. I hope you understood what is the problem I'm having because of the time limitation. So I want to give a lot of things for you, but time will be a problem. Now we were here. I used the center point arc tool. If you want, you can use another one called say 3-point arc. Say I will use the 3-point arc. First, we can give this point, and another point somewhere. I don't know the point actual place. I just do it. So what happened when I draw this kind of a thing is center point moves to somewhere else. Center point should be here. So the center point should be coming to this origin. So you can select this point as well as this point. Press the control button, and we can give a relationship called coincident. Coincident relationship can be applied. So you can see now this is moving here. Center points are matched, and this is now becoming a fully defined sketch. So what I did was I fill it again and do it. We got the 3-point arc. Gave the first point, second point, third point should not be here. It should be this side. Just give somewhere. If you want, you can apply dimensions, or else coincide this point and this point. Or else you can apply a dimension. Say I will apply 10. Automatically the center will move. This is also possible. Now you can see it's not going to be overdefined because this relation is not given. 10 can be given. Or else you can do what? You can click on this and click on this and make it constant. Now if you try to give 10 here, there will be problems. There is problem. I hope you understood, because I gave the relation here. I don't need to give again a dimension. So relations will cover the dimension job. So either you can give a dimension or a relation. Don't need to give both. Okay. So I got my final outcome. So you can try this. I will give you time. Try this and see. If you have any questions again, tell me. Now I will save this file for you. Now when I try to save this, this is saved it as a SolidWorks part model. So I will save this in our folder. We will have a folder for our work. So normally we should save everything in a folder. Don't save it here and there. This is chapter 2. So this is saved as a SolidWorks part model. If you want, you can save it as a AutoCAD drawing. If you want, you can save it as a Adobe Photoshop file, or a PDF, or a JPEG, or you can save it in different third-party formats like IFC, STL, IFC, step files, IGS. So these step files, IFC, IGS, those STL, VRML. So these files will be supported by a lot of software. So if you want to transfer this to another software, step files are the best, or IFC. So if you want to do some surface modeling, VRM, so STL. So there are a lot of third-party formats coming to when it wants to transfer. So you have CATIA files, Pro Engineer software, AutoCAD, DXF is also supported by AutoCAD and Photoshop. So a lot of versions are available. I'm just using the SolidWorks mode. and save. So when you save this, it's still a 2D sketch. If I go and look at the folder, this is saved here. So I can get a thumbnail view. So now what we do is, we are going to make it 3D. Any questions about this 2D sketch? So if you finish with the 2D, you have to make a 3D model from this 2D sketch.
Actually, it doesn't seem to be working, sir.
I didn't get you. You don't have the software.
No, sir.
They have sent you an email.
Yeah, but that doesn't seem to be working, sir.
It's not working?
Yeah,
It's not working, sir.
So we better inform Miss Chaturika.
She said that's the only version she has.
So it doesn't working means that the Windows Defender DS there is malware, so it not allows to install that.
Can't you switch off that one, malware? Windows Defender. You try to switch.
Some of us got the software somewhere else, but that leak says it has malware.
I think that's because it's a crack file. So you can switch off the Defender and try to install. I am having Windows 7. The main reason I am having Windows 7 is Windows 7 nicely support all the software. Not like Windows 10. There are some problems with the latest Windows. Anyway, you need to have the software somehow. Try to get it from a torrent even. Otherwise, you can't follow this lesson. So, any questions about this one? Shall I make it a 3D?
So I have some question. Then some of lines of my sketch is state in blue color. Some of lines are in black color.
Yes. You should have all the lines black color. Blue means you haven't given adequate amount of relations or adequate amount of dimensions. Check whether you have given relations like equal here, equal here, equal here. All these 3 lines should be equal to these 3 lines, and this should be equal to this line, and it should be symmetric. So, and try to give the dimensions and try to make it a fully defined sketch. Just do it and see. So this is the problem of this kind of subjects, since I'm not available there to help you. Try to get it fully defined. We will do a lot of tutorials, then you will understand what I'm saying. So this is the starting. Don't worry about so much. You will get used to the software. Now we will make it 3D. So we will give a thickness. So the thickness value is actually not given in the sketch. Not given. So it's actually 10 millimeters or 5 millimeters. So we can give a thickness to the drawing. So what we can do now is we will make it a 3D. So this is my drawing. So how did I rotate my drawing is, I just press the middle button of the mouse. So you need to have a mouse when you work with SolidWorks. It's easy. Have a mouse, otherwise it's going to be difficult. So I rotated my model using the mouse middle wheel. So if you don't have a mouse, there will be problems. You have to right click and get these tools here. So you have the rotate tool like this. So it's difficult without the mouse. You have to do a lot of right clicks, and you have pan tool. Pan tool will allows you to take it here and there. So if you have a mouse, you need to just press the Press the control key and the middle wheel, you can pan it. I am pressing the control and the middle wheel, you can pan. Otherwise, you have to right click and get the pan tools. Zoom in, zoom out, I can just rotate the wheel up and down. You can zoom in and zoom out. If you don't have the mouse, you have to use these zoom tools here. Zoom in and out without the mouse. And there are zoom tools available here also. Zoom to area, that is you can select an area like this and zoom. And there's another one called zoom to fit. It's fitting the, trying to fit your drawing to the screen. So this may be helpful when you do a drawing. Zoom to area. You have to make sure there is no holes in these joints. It should be a closed loop. You cannot have even a tiny hole. Everything should be connected with each other. Otherwise, it may not become a 3D model. So I have to go to these features here and select this extrude tool. So I am still in the sketch mode. If you want to quit from sketch mode, just press this button. You will be quit. So I quitted from the sketch mode. You can see it's now light gray colors, no dimensions, no relations. I have quit from the sketch. So if you want to make it available again, you right click or left click and go to edit sketch. You can right click or left click. If you left click, you will get a limited number of options. If you right click, you will get these options also and this. So I can click on this and come back to the editing mode. Quit from here and start from here. So I am in the sketch mode again, and you can go to directly, or you can exit from here even. Exit here. So a lot of ways of exiting. Exit from here or else. I am in the sketch mode again. Now we have to go to feature mode and make it a 3D part. So I am going to use the extrude feature. There are a lot of features available in SolidWorks. The easiest one is the extrusion feature. We have revolve feature, we have swept boss, swept feature, loft feature, boundary, lot of features available. Some are not working because of the drawing limitations. These are not working. So I can extrude this now. You can see what happens. It makes a 3D model. So the extrusion length is 10 millimeters. So we can change it to say 20. Likewise, we can change it to whatever the value I like. Press enter. So I'll make it 10. And if you want, you can drag it from this one also. There is a ruler coming. You can snap to these values 80. Likewise, you can snap to the ruler. Or else you can go to the other side even. Or else if you want to change the side, you can use the arrow tool, reverse the arrow from here even. So this is a blind value I gave. Blind means I'm just giving the value blindly. There are other options available here. We will look at these later. And these options we are going to look at later. So I'm starting from my 2D sketch and gave a blind value called 20 millimeters. And if it is okay with you, you can press the finish button. So I just introduced the extrusion tool. There are a lot to learn. We will do it later. So this is my 3D model. Now you can see the feature has become extrusion feature, boss extrude one. And you can expand this one and get the sketch also. So if you want to do some editing again, go to edit sketches and do editing. Say I will edit it, say 70. This is the beauty of SolidWorks. I edited it. Now I can quit. It is adjusting to 70. Your drawing is still fully defined. Still fully defined. So if you want, you can make it like 20. You can see it's nicely adjusted. Now there's a problem comes. So I didn't give a lot of relations. You can see the problem here. So when I try to make it 20, there is a problem in the drawing. So I haven't, even though it's fully defined, I haven't given adequate relations. So that's why the problem comes. So we have to make sure when it comes to editing, our drawing should maintain the same shape. So this is how it works. So if you want, you can double click on this and get the dimensions also. Double click on the model and change this. It's also possible. And okay, if the change this didn't happen, you can come here and rebuild your model. It's like refreshing your sketch. Yeah, then now there is an error popping up. You can see there is an error in my sketch. Adding more dimensions or relations to further define the sketch. Changing the dimensions. So this is what happens when if you don't think about a drawing critically and draw. So you have to avoid these kind of things. These are coming when you are trying to do an editing. So I haven't done it 100% correctly. That's why I am getting these errors when I try to edit my drawing. So we will see what happens. Say I will delete this now, this feature, and take the sketch back. I took the sketch back. I will go to edit sketches again and see what happens in my drawing. So we can make it perpendicular. So you can make it perpendicular from this small button here called normal. Now I will try and see what went wrong in my sketch. So you can also make it 3D and see. So I will delete this fix button. It's not needed. Actually, it's not needed. And this is over defining the sketch, so it's not needed. So this is should be 60. Sixty, 10, 35, 10, 20, 10. Okay, it appears okay, but when it comes to editing of this small part, there are problems coming. 15. Change the should result invalid geometry. So you can see I have given lot of relations. So when I try to change this to 15, it exceed this value. So if you give 15 here, it's 15 here, 30, 15 here, 15 here, 30 plus 30, 60. Then there's a problem. That's why when I try to make it 15, it gives me this one invalid geometry because there's a 60 here. So you can see the constraints I have. Say I can make it say 80. Now it's nicely adjusting. So if I try to make it 15 again, it's adjusting now. No problem. So there are some constraints due to the total length here. Total length is 80. So I hope you understood what I'm saying. You cannot do a lot of changes because there are limitations. The total length is a limitation. So you have to understand those relations when you try to do an editing in your model. Still, it's normally there's no problem still. So it's changing nicely. So you have to make sure there's a limitation with the total length. So if I try to make it 60 again, it's okay, it's not distorting. So now if it is okay, you can come here and make it a 3 and change the sides, change the value. And if you want to have two different thicknesses, now this is 20 millimeters. If you want to add to say 10 millimeters to this side, you can start the direction 2. Direction 2 will have 10 millimeters to the other side. So this is 20 millimeters to the front side, 10 millimeters to the back side. So okay, that can be also done. So I have two different values, 20 and 10. So you can switch off this one also. So I hope you understood the basics. And if I want to apply a material here, now the material is not specified. So I can right click and get some basic materials from this list. So if I want to apply nickel, you apply the nickel. Or if you want to apply some brass, just apply the brass color. So this will apply the actual material, then you can calculate the weights and the other things. So we will look at those later. So you can just apply a material from the default list here, or else you can go to edit materials and get the big list. There's a big list here, so you can get whatever the most accurate material from this list. And if you want to have your own materials, you can create your own materials. That is, if you are doing a research, you can create your own materials and see, and apply loads and see whether this material is going to exist. So there are a lot of things we can do. So I hope you understood this thing. So I will save the file. So if you look at my tutorial folder, now the thumbnail has changed to a 3D shape. So this is my content. Any questions about this? We will try to do another tutorial before the break. Me to do it again, let me know. I will come back in 1 minute. Any questions about this?
Yeah, I have also, sir, my all the vertical lines are black, horizontal lines are blue. I can't understand why is that.
Did you put the dimensions like me?
Yes.
Actually, I don't need to give this 20 again because this is equal to this one. So if you want, you can delete this 20 and have a equal line. Sorry, I'll delete this. You can make it this line equals to this line. That's also possible without giving 20. And what I did was I made this one equal to this one. This line equals to this line. This line equals to this line. And I make sure that this is symmetric. This line is symmetric. This portion is symmetric. These two symmetric. These two symmetric. Then it should work. Just check whether what happens, especially if you, and you have to give this 10. If you delete this 10, these lines will become blue. See whether the measurements are given and the relations are enough. So if this is equal to this is equal to this, these lines are equal to these lines, and symmetricity also given. I didn't give this one equal to this one because the symmetricity is there. If you want, you can make this line equal to this line. That is not a must. Even though if you give more relations, there will be no errors come. But if you give more dimensions, there will be errors come. So 10 of everything is given. Now, if you want to make this one, if you apply the extrusion operation, what happens here is it will extrude something like this. So which is not my requirement. So extrusion works this way. You know about that. So this is the extrusion operation. So it is not my, it's not the thing I want. It's not my requirement. So extrusion will not going to work here. I will delete that. So I drew this center line to get the symmetric sketch. This center line is to get the axis, revolve axis. So what I want to do is I will go to a sketch mode again and apply the second operation called revolve. So when you apply the second operation called revolve, software will ask me what is the axis you want. Since we have two center lines, he cannot choose. So we have to choose the center line for the software. And this is the blue box. You have to give this center line as the axis. So once you give this as the axis, it will generate the 360-degree revolve part. 360 degrees. Now actually I want 270 degrees only. So this is the part I am generating. So if you want to change the direction, you can change it like this. I hope you understood what I am doing. So the section is this, and I am getting the 3D revolve part. That's okay. This is the outcome. So this is how it works. So doing getting the 3D is not a difficult thing. So the difficult thing is to do this sketch correctly. Fundamentals. This is the fundamental. So getting this 3D is not a difficult thing. Any questions?
Yes, sir. Can you do the revolving thing again, sir?
So I hope you have this one. Even you have an underdefined sketch, no problem. You can make it 3D. Now if you delete this 110, it's going to be underdefined. So sorry, my machine is somewhat slow. That's why you are getting these kind of problems. I'll delete this. Now this is underdefined. But it's not a problem for the revolve tool. But the problem here is when it comes to editing, I don't know what it's going to have after I did this 50. So that's the problem. So underdefined sketches also can be made 3D, no problem. Revolve and get the center axis. Now if you haven't drawn this line, somebody may not have drawn this. So you say, if I delete this, you don't have a line. So what happens? When I start the Revolve tool, he will select this center line as the axis, because he always search for the center lines, not for the normal lines. So we have to delete this and select this as the center line. This can be also selected as a center line for the axis. Same result. Okay, so you can have a center line and do it properly, or without the center line like this also you can do it. Okay, and I have to give the value, say 270. Direction, if you want, you can change it and press OK. So there are different approaches. If I go to this sketch again, we can draw the center line, always select this as the axis. So we will apply the dimensions again. Even in the 3D mode, I can do that dimensioning, no problem. Now it's going to be fully defined, and you can exit. So this is how it works. Okay, any questions? Shall I move on to the next tutorial? So this is actually a tutorial based session. When I need the tools, I will teach that theory part. So we have learned about the line tool, center line tool. We didn't learn about this one still. And we learned about arc tools. So gradually we will learn a lot of tools from this list. Now next tutorial is about we are gradually increasing the complexity. Now, I want to model this kind of a shape. So when you see this kind of a shape, you have to immediately get into your mind that this should be done from extrusion tool, because it doesn't involve any revolve methods. It doesn't have any round shape. It has a certain thickness, so you should get a extrusion tool to work. So to draw the to get the extrusion, you have to draw that front shape. So the front shape is given here. So that's how we approach to these things. We have to understand what is the 3D tool I want and what to draw as the 2D sketch. So I have to draw this as the 2D sketch. So this involves a circle tool and an arc tool and some lines. So I will start this one and show you how it works. For the first few tutorials, I will do it with you and show you how it works, how you should do it. So we can start from the line tool. Where I can start. If I start from here, I can complete up to here, up to here, up to here. But better you start from here. Then you can complete lot of areas from the line tool. Then comes to these. So we don't start from circles because it's not very advisable. Just start from the line tools and put the relation dimensions and have a stable or defined broad. So I will start a new one. Start. And front plane I'll take as usual. And now this is the center. Now here center line is here. If you want, you can make this as the center of the circle, or else you can make this point as the origin. So there are a lot of ways of doing this because this is not a perfect symmetrical design. We can start from here even. So this can be the origin. Try to get the origin into your drawing, then it's easy for you to make it fully defined. So I will try to have somewhere here also okay, somewhere here also okay. I will not take this here, this point here. I will I will think this is the origin. So we can have something like this. So I'm trying to get the origin into my drawing, then it's easy for me to make the drawing fully defined. So that's what I'm thinking. Something like this. So I hope you understood. This is the origin location in my drawing. So I'm trying to take it into the lines, not to the circles. Then it's easy for me to make it fully defined. So sketch is done. Now we can see some. We have to think whether there are relations. The easiest relation I can think about is this one. This is equal to this height. So even though this looks like equal, this is not equal. So you have to make sure these are equal. Select this line. Make sure you select the line, not the midpoint. Select the line, and make it equal. Equal is equal. Then now when I edit this, it's nicely moved. No problem. If you want, you can make this as collinear. I don't need that here. Collinear. In a single line. Collinear. I don't need because this is equal at the moment. If you want, you can make it collinear. If you talk in singular, this is ekareki. Ekareki karana two. So this is equal. No need to have collinear. That's all I can think about. So no other relations are obvious. So what we will do is, without drawing this, I am not coming to this one. I will put the dimensions and try to make a fully defined sketch. 150. This is 20. So get the lines. Then this is 35. This is 25. You can see the lines are becoming black now. And from here to here, it's 15. This is 40. Now, lot of lines are becoming black, but one is blue still. The problem is this one I didn't give any measurements. Carefully look at this. This point and this point are in the same plane. So what we can do is, we can try to make it shorten like this manually and do something like this. Still this is blue. Now we can draw these other circular parts. So I will try to draw this arc. We can use this 3-point method or tangent arc. Tangent arc is starting from here and like this. So I drew the tangent arc and I have to give a measurement. It's 30.
So my lines are still blue, but I have given the dimensions like 150, 20, 35, and 25.
Did you give this equals to this one
Uh,
or collinear?
okay.
Try to give
No,
this one equal to this. Then try to give collinearity.
so, how to give this one equal to this function? Sir?
You can click on this, press the control key, press this line, and get the equal here. That's the only relation we should give and make. I'm having the origin here in the drawing itself, so then it's easy. Then now this is fully defined in my one. So then I have to draw a circle in the middle. Circle is diameter is 30. So you can use this tool, circle pair. This tool first define the center of the circle and give a radius. This tool is we want to give 3 points in a sketch, then it will define the circle. The first tool is we give the center and the radius. So here in my case I can use the first tool. I can use this one, center is obvious. I can just draw the radius. Radius is, I can put the smart dimensions here. Diameter is 30. Normally for the circles we put the diameters. For the arcs we put the radius. So this is the sketch. And it's fully defined. So you just think you can do it and see whether it's fully, you are getting it correctly or not. If you have any questions, let me know. Just try this one. And we'll have a small break. We will meet at 11 o'clock for the next session. So you can do it within the break, and any questions, let me know. I will come back in at 11 o'clock. We will meet at 11 o'clock.